Hello everyone, this is Yutanshi from CSIT. Today I'm going to tell about design, implementation and deployment of the iKP secure electronic payment system from software project management. Introduction. iKP or Internet Key Payments is a cutting-edge electronic payment system designed to ensure the security and integrity of the online transactions. Leveraging advanced cryptographic techniques and robust authentication protocols, iKP aims to safeguard sensitive financial information, mitigate the risk of fraud, and facilitate seamless digital payment across various platforms. This presentation develops into the design, implementation, and deployment of the iKP, offering insights into its architecture, security measures, implementation process, deployment strategies, and future enhancements. Developed to meet the escalating demand for trustworthy digital transactions, iKP offers a robust framework with cutting edge cryptographic protocols and authentication mechanisms. In an era where online commerce dominates, iKP rises to the challenge, ensuring the confidentiality, integrity, and authenticity of the payment data. Payment system provider, issuer, acquire, buyer, seller, clearing payment. This figure shows the model of a payment system. Secure Electronic Transaction Protocol. Secure Electronic Transaction or SET is a system that ensures the security and integrity of electronic transactions done using credit cards in a scenario. SET is not some system that enable payment, but it is a security protocol applied to those payments. It uses different encryption and hashing techniques to secure payments over the internet done through credit cards. The SET protocol was supported in development by major organizations like Visa, MasterCard, and Microsoft, which provided its secure transaction technology, and Netscape, which provided the technology of secure socket layer SSL. SET protocol restricts the revealing of credit card details to merchants, thus keeping hackers and thieves at bay. The SET protocol includes certification authorities for making use of standard digital certificates like X509 certificate. Participants in SET. In the general scenario of online transactions, SET includes similar participants: cardholder, issuer, merchant, acquirer, certificate authority. Cardholder relates to the customer. Issuer relates to the customer financial institution. Acquire relates to merchant and financial authority that follows certain standards and issues certificates to all other participants. Design principles of iKP. iKP is specially crafted around several core design principles aimed to in the security and reliability of electronic transactions. First one is cryptographic foundations. iKP relies on robust cryptographic algorithms and protocols to safeguard sensitive data during transmission and storage. Encryption techniques such as RSA, AES, and digital signatures ensure confidentiality, integrity, and authenticity in every transaction. Key management. Central to iKP's design is an efficient key management system that governs the generation, distribution, and storage of cryptographic keys. Through secure key exchange mechanisms and key rotation policies, iKP maintains the integrity of cryptographic operations while minimizing the risk of key compromise. Multi-factor authentication. To fortify user authentication, iKP employs multi-factor authentication mechanisms that require multiple forms of verification such as passwords, biometrics, and token-based authentication. This layered approach enhances security by reducing the likelihood of unauthorized access. Transaction integrity. IKP ensures the integrity of transactions through robust validation mechanisms and digital signatures. By verifying the integrity of payment data at each stage of the transaction lifecycle, IKP mitigates the risk of tampering and unauthorized modifications. Compliance and standards. IKP adheres to industrial standards and regulatory requirements to uphold the trust and confidence of stakeholders. Compliance with standards such as PCI DSS Payment Card Industry Data Security Standard and General Data Protection Regulation GDPR underscores IKP's commitment to data protection and regulatory compliance. These design principles collectively form the bedrock of iKP's architecture, empowering it to deliver secure, reliable, and compliant electronic payment solutions in today's dynamic digital landscape. Components of iKP. iKP comprises several interconnected components, each playing a vital role in ensuring secure electronic transactions. Merchant server. The merchant server serves as an interface between merchants and the iKP system. It facilitates transaction processing, manages order fulfillment, and communicates with customer wallets and payment gateways. Customer wallet. The customer wallet is a digital repository where users store their payment credentials such as credit card information, digital wallets, or bank account details. It securely stores sensitive information and facilitates secure transactions with merchants. Payment gateway. The payment gateway acts as an intermediary between merchants and financial institutions, facilitating the authorization and settlement of transactions. It encrypts payment data, performs fraud detection, and ensures compliance with payment card industry standards. Issuer bank. The issuer bank is the financial institution that issues payment cards, example credit cards, debit cards, to customer. It authorizes transactions, verifies cardholder information, and manages the transfer of funds between accounts. Acquire Bank. The Acquire Bank is the financial institution that processes transactions on behalf of merchants. It receives transaction requests from merchants, verifies their authenticity, and settles funds into the merchant's account. Audit and logging mechanisms. Audit and logging mechanisms record transaction details, system events, and user activities for security and compliance purposes. Comprehensive logging facilities. Forensic analysis, anomaly detection, and regulatory compliance reporting. Understanding the interplay between these components is essential for grasping the architecture and functionality of IKP, thereby ensuring the secure and efficient processing of electronic payments. IKP architecture. Internet Key Payment Protocol. This architecture shows the payment system provider. iKP architecture. The iKP architecture is designed to provide a robust framework for secure electronic payments. It comprises several interconnected layers and components. Presentation layer. The presentation layer is the interface through which users interact with the iKP system. It includes user interfaces such as web applications or mobile apps that facilitate the ingestion and management of electronic transactions. Application layer. The application layer consists of business logic and transaction processing components responsible for facilitating the flow of payments within the iKP system. It includes functionality for authentication, authorization, transaction validation, and error handling. Security layer. The security layer encompasses cryptographic protocols, encryption mechanisms, and authentication protocols aimed at safeguarding the confidentiality, integrity, and authenticity of payment data. It includes techniques such as SSL, TLS encryption, digital signatures, and tokenization. Transaction processing layer. The transaction processing layer manages the end to end processing of electronic transactions from initiation to settlement. It interfaces with merchant servers, payment gateways, issuer bank, and acquire banks to facilitate authorization, clearing, and settlement of transactions. Data storage layer. The data storage layer stores transactional data, user profiles, payment credentials, and other essential information in secure databases. It includes components such as relational database, NoSQL database, and data warehouses optimized for performance, scalability, and data integrity. Integration layer. The integration layer facilitates seamless integration with external systems such as third-party payment processors, financial institutions, and regulatory compliance system. It includes APIs, middleware, and message queues that enable interoperability and data exchange between disparate systems. Infrastructure layer. The infrastructure layer comprises physical and virtual infrastructure components, including servers, network, storage systems, and cloud computing resources. Security measures in iKP. iKP employs a comprehensive array of security measures to safeguard electronic transactions and protect sensitive data. Encryption techniques. iKP utilizes strong encryption algorithms such as advanced encryption standard and reverse entrapment to encrypt sensitive data during transmission and storage. Encryption ensures that payment information remains confidential and secure from unauthorized access. Digital signatures. Digital signatures are employed to verify the authenticity and integrity of transactions within the iKP system. Each transaction is using cryptographic keys, enabling parties to verify the identity of sender and detect any tampering or modification of transaction data. Tokenization. To mitigate the risk of exposing sensitive payments credentials, iKP implements tokenization techniques. Tokenization replaces sensitive data such as credit card numbers with unique tokens that have no intrinsic value, reducing the impact of data breaches and enhancing security. Multi-factor authentication. It encompasses multi-factor authentication mechanisms to strengthen user authentication process by requiring multiple forms of verification such as passwords, biometrics, and one-time codes. IKP enhances security and mitigates the risk of unauthorized access. Fraud detection and prevention. Advanced fraud detection algorithms and machine learning models are employed to identify and prevent fraud transactions within the IKP system. Real-time monitoring, anomaly detection, and transaction pattern analysis enable early detection of suspicious activities. Security auditing and logging. IKP maintains detailed audit logs of system activities, user interactions, and transaction events for security auditing and for analysis purposes. Comprehensive logging enables administrators to track user behavior, investigate security incidents, and demonstrate compliance with regulatory requirements. Regular security assessments. Regular security assessments, penetration testing, and vulnerability scanning are conducted to identify and remediate potential security vulnerabilities within the IKP system. Implementation of iKP. The implementation involves systematic process encompassing several key stages. Step 1, Requirement Analysis. The implementation process begins with a comprehensive analysis of business requirements, functional specifications, and security considerations. Step 2, Design Phase. In the design phase, architects and blueprints, system diagrams, and data models are created to translate requirements into a tangible system design. Step 3, Development and Coding. The development phase involves writing code, building components, and implementing the functionality outlined in the design phase. Step 5, Testing and Quality Assurance. Rigorous testing and quality assurance procedures are conducted to validate the functionality, performance, and security of the iKP system. Unit testing, integration testing, regression testing, and security testing are performed to identify and address defects and vulnerabilities. Step 6, Integration and Deployment. Once development and testing are complete, the iKP system is integrated with external systems such as payment gateways, merchant servers, and financial institutes. Steps, Monitoring and maintenance. Post deployment, the iKP system is continuously monitoring to ensure optimal performance, availability, and security. Step, User training and support. User training sessions and documentation are provided to educate stakeholders on the features and functionality of the iKP system. Help desk support and troubleshooting resources are available to assist users with any questions or issues they may encounter during system operation. By following a structured implementation approach, iKP can be successfully deployed and operated to facilitate secure electronic payments, meeting the needs of business and consumers in the digital economy. Future enhancements. The future of the iKP secure electronic payment system holds exciting possibilities for further innovation and enhancement. Key areas for future development include advanced biometric authentication. Integration of advanced biometric authentication technologies such as facial recognition and fingerprint scanning can enhance the security and user experience of the iKP. Blockchain integration. Integration of blockchain technology can introduce new levels of transparency, immutability, and decentralization to the iKP system. Enhanced fraud detection algorithms. Continued refinement of fraud detection algorithms using machine learning and artificial intelligence can boost the fraud detection capabilities of iKP. By leveraging big data analytics and anomaly detection techniques, iKP can proactively identify and mitigate emerging fraud threats in real time, safeguarding transactions against fraudulent activities. Smart contract integration. Integration of smart contracts. Programmable self executing contracts based on blockchain technology can automate and streamline contractual agreements within the iKP system. Smart contracts enable automated execution of payment terms, escrow services, and dispute resolution, enhancing transaction efficiency and reducing manual intervention. By embracing these future enhancements, iKP can remain at the forefront of secure electronic payment systems, delivering unparalleled security, convenience, and reliability to users and business in the digital economy. Conclusion. In conclusion, the design, implementation, and deployment of the iKP secure electronic payment system represent a significant milestone in ensuring the security and integrity of digital transactions. By adhering to rigorous design principles, leveraging advanced security measures, and adopting best practices in implementation and deployment, iKP offers a robust framework for conducting secure electronic payment in today's dynamic digital landscape. The architecture of iKP, fortified with encryption techniques, multi-factor authentication, and fraud detection mechanisms, underscores its commitment to safeguarding sensitive data and mitigating security risks through a comprehensive array of security measures, including encryption techniques, multi-factor authentication, and fraud detection mechanisms. iKP ensures the confidentiality, integrity, and authenticity of transactions, instilling confidence among users and stakeholders alike. Thank you.